Hello. Fear is being created by implying that graphene has been in vaccines since 2021. But how many know what graphene is? Does it exist? Is it present in vaccines? Graphite, a crystalline form of carbon, has been known since ancient times. It has been known since at least the Middle Ages that it crumbles easily when rubbed and leaves a mark that is blacker than lead. Once the crumbling process was technically mastered by French inventor Nicolas Jacques Conté in the 16th century, it came to be used to make pencil leads. Writing with a pencil leaves a thin layer of graphite on a sheet of paper. In graphite, planar sheets of carbon atoms with each atom bound to three neighbors in a non-compact honeycomb structure are stacked regularly with three-dimensional order. Graphene was defined by chemist Hans Peter Bohm and his co-authors in 1986 as a single layer of carbon atoms in the structure of graphite. But the term is now frequently applied to stacks of several layers of graphene. The interest in graphene, even before its supposed discovery, stems in particular from the fact that it is a semiconductor, namely between a conductor and an insulator. But unlike conventional semiconductors, it has a very high conductivity and is therefore of great interest in electronics. This supposed discovery dates back to 2004 and earned its authors the Nobel Prize in Physics. But several questions arise. According to the definition, a single layer of graphene should be the thickness of a carbon atom. This is the distance between two carbon atom nuclei, namely the length of single carbon-carbon bonds in organic compounds. It is about 0.154 nanometers. To observe graphene monolayers, the authors used an atomic force microscope. Such a microscope can achieve a resolution of 0.1 to 0.2 nanometers, which is at the limit of what is theoretically observable. Furthermore, it does not allow the distance between the surface of the sample and the tip of the microscope to be measured directly. Either the forces between the sample and the tip are measured without contact, in which case the distance is deduced indirectly and depends on the material being observed. Logically, this seems to imply the need for a means independent to the microscope to estimate the relationship between the actual distance and the value found by microscopy. The distance between the tip and the sample can also be measured by contact. But this risks altering the sample. And at this scale, how can we know the exact moment when contact is made? In fact, they observed folded monolayers. A single-layered graphene was rarely found completely flat, and we often observed some areas being ruptured and folded back, as well as splitted areas. The measured dimension is approximately 0.8 nanometers for a double fold and 0.4 nanometers for a single fold. From this, they deduced that it is a monolayer. However, in some places, the images seem to show bubbles between the folds. So is it really a single monolayer? The rest of the work was done using a scanning electron microscope. Its maximum resolution is around 1 to 20 nanometers, which implies a thickness of at least 7 layers of graphene. However, according to the ISO, the International Organization for Standardization, after 10 layers the properties change and it is no longer graphene. Therefore, the observation of graphene using such a microscope is highly questionable, and they admit that they believe to have in fact observed stacks of layers using this method. Let us emphasize that all means of observation create artifacts. An artifact is damage caused by a preparation technique and can easily be confused with the sample's microstructure. And in the case of an electron microscope, may also be produced due to irradiation under the electron beam. In particular, even if the vacuum is ultra-high, there are always carbon atoms from the microscope components, and the electron beam could deposit them on the preparation. Boehm acknowledges this as a possible source of error in his work published in 1961, in which he observed and isolated stacks of graphene sheets. Although he minimizes this possible contamination by carbon, which in the case of graphene could distort the observation, he acknowledges that obviously the extent of this contamination is very uncertain. Furthermore, the preparation method raises questions. It involves mechanical exfoliation, namely repeated peeling with cellophane-based adhesive tape. In other words, Scotch tape. To quote Boehm, if the adhesive tape with a thin graphite layer is pressed into a thin SiO2 silicon dioxide coating on a silicon wafer, the graphene layers remain attached to the CiO2 surface after skillfully peeling away the tape. However, it is possible that glue residues could remain. It should not be forgotten that we are talking about dimensions 10 times smaller than 1 nanometer, and therefore tiny amounts of foreign matter could contaminate the preparations. Most microscopists are not trained for such delicate work. But even in the best case scenario, can we say that there are no artifacts? Furthermore, we must pay attention to the theoretical aspect. Is it legitimate to apply concepts such as surface contact forces and theories developed for macroscopic structures to dimensions well below 1 nanometer? Shouldn't we verify experimentally without resorting to these theories, but with methods appropriate to this level of smallness? In other words, developed as a result of observation using methods that are not themselves based on theories resting on observations at the macroscopic or even microscopic level? Shouldn't we have independent means to verify the exceptional properties attributed to graphene, such as its strength, which is said to be the greatest known, greater than that of steel? What do we mean by a sheet less than 0.2 nanometer thick being stronger than steel? Is such a comparison even possible? In any case, even assuming that graphene has indeed been discovered, what is marketed as graphene is often not graphene at all. Physicists themselves warn against this. According to a study by researchers at the National University of Singapore, it is alarming to uncover that producers are labeling black powders as graphene and selling them for top dollar, while in reality they contain mostly cheap graphite. In any case, the methods developed remain limited to small quantities, and it turns out that graphene layers have only been observed when placed on a solid macroscopic structure and are therefore not independent of the structure. Moreover, can we be sure that observation can differentiate a monolayer from the substrate? So it seems unlikely that vaccines contain graphene, even assuming that such a material exists. There are other reasons given by Dr. Stefano Scoglio. It should be noted that the right-angled structures resembling cities observed by some in products injected since 2021, which are said to be due to graphene, have been observed for a long time in solutions containing salt, body fluids, or saline water. It is salt crystallization. That there are nanotubes, namely tubes consisting of folded graphene sheets, yes, that could be the case. They have been known for a long time, but their properties are not those of graphene. The subject illustrates the problem of current research. As physicist and mathematician Edward Carpenter noted in 1889, each science has been reduced to its simplest terms. All the wonderful phenomena of physics are emptied down to a flight of atoms. 2 decades later, Henri Poincaré wrote, "We seek reality, but what is reality? If you are present at a game of chess, it will not suffice for the understanding of the game to know the rules for moving the pieces. This knowledge will truly have very little value. To understand the game is wholly another matter. However, the simple is made to look complicated, the absence of solid foundations for a theory is obscured, and attention is diverted from the basic questions by a complexity, particularly mathematical, in which researchers themselves can become lost. Driven by funding and prizes, research is now fully entrenched in the global marketplace. Financial gain has become a key motive in a culture where researchers themselves create companies to exploit their discoveries financially. Of course, most researchers do not have harmful aims, but like everyone else, they are susceptible to the prevailing culture and the education they have received. How many still conduct experiments in the spirit of falsification and therefore of doubt, which guarantees the value of a theory? Doubt is essential because our scientific theories are far from objective, a point that scientists of all times and cultures have emphasized. The motto of the oldest scientific organization founded in the 1660s, the Royal Society of London, is nullius in verba, take no one's word for it. This does not mean rejecting a theory out of prejudice, nor does it mean accepting it passively. The next video will address the issue of political enthusiasm for graphene and more generally nanoparticles, which is very real. Let us not forget the words of literary critic Desmond McCarthy on the occasion of the splitting of the atom in 1932. The destiny of man slipped from the hands of politicians into the hands of scientists who know not what they do but pass responsibility for results on to those whose sense of proportion and knowledge are inadequate to the situations created by science. Thank you.